Did you know you can use one of these, an Arduino, to speed match your model railroad locomotives? Now, today we're going to talk about how to do that in a very easy way and why you would want to speed match your locomotives in the first place. Before we begin, I'll go ahead and tell you that I'm planning on doing a speed matching video because it's a process that deserves its own video. I'm planning on doing that a couple episodes from now, so make sure that you are subscribed so that you do not miss that video. Okay, so first of all, why would you want to speed match? Well, speed matching is pretty much exactly what it says it is, where you're matching locomotives' speeds. So basically, when you get DCC locomotives and you can put decoders in them, even if they're from the same models and same manufacturers, they're not going to be exactly the same. They're going to have some differences in their motors or just the parts that they may be slightly different. It's going to cause their speeds to be slightly different. So when you speed match, you can make it to where the locomotives run the same and you can hook them up together in consist, that's where they're hooked up together, and they can use their combined pulling power to be able to run longer trains, to run more realistic trains. So if you like saying have like FA and FB units, this is a way to do that. Or if you like doing those modern locomotive sets where you have like 3, 4, 5 power units on there, this is how you do it. You have to speed match the locomotives. Otherwise, you're going to have issues with either straining the locomotives, the couplers, and it's just going to be a bit of a headache. So speed matching is a process for doing this. Now, we are going to build a device today with an Arduino that's going to aid in the process of speed matching. It's not only going to make it faster, it's going to hopefully make it a lot more accurate. So let's go ahead and get into the build. These are all the components you're going to need for the build. It includes an Arduino Uno, a breadboard, some DuPont connector wires, some infrared sensors, and a 2-line LCD screen. Now, this is a pretty long tutorial, so I'm going to put time codes in case you want to skip around right here, and also I'm going to have all these parts linked in the description below. The first thing we're going to do is we're going to take our Arduino and connect our 5-volt and ground into the bus columns on the breadboard. This is just so we can distribute out the 5-volt power and the ground connections, and it's going to make it easier to hook everything up. Next up, we're going to go ahead and do our connections from that power distribution column to where we're going to connect our infrared sensors to it. They each need to be powered with a 5-volt and ground connection, and then we're also going to have separate wires that go to their inputs on the Arduino, which will be pins A0 and A1. Now that the power connections are made, we can make those sensor connections. Now, pay attention here. I'm going to be using a yellow wire for A0 and a green wire for A1. A0 is going to be the number 1 sensor, and A1 is going to be the number 2 sensor. This is important for the sketch because sensor 1 needs to be tripped before sensor number 2. So pay attention to which one you're hooking up to which input. And that is our entire setup for the base version of this project. So let's go ahead and write some code. All right, everyone, we're in our Arduino IDE, and the first thing we're going to need to do is set some variables. Now, we're going to be using one called unsigned long, which you've not seen me use before, and we're going to call that one time 1, and that equals 0. So that's going to be our start value for that. But unsigned long is basically for the longer numbers, 4-digit numbers, which we're going to need in this case. Next one we're going to do, we're just going to do int sensor 1 is equal to A0. We're going to do int sensor 2 is equal to A1. And then we're going to do a couple more unsigned longs. I'm going to call this one start millis. You can call it whatever you want, really, and we'll call that one equals 0. And that's going to be your first reading from the sensor, and that's what it's going to save it as. And then we're going to do unsigned long end millis, and that equals 0. Now, a couple things. The reason I said time 1 is because if you'll notice, when I delete the 1, all of a sudden time becomes a function. So we're just going to go ahead and do that 1, and that keeps it just being a custom variable. So that is just everything that we need to declare right now. We're going to come back when we do some modifications, but let's go ahead and add in our setup. So we're going to do void setup. And then the first thing we're going to do is we are going to do serial.begin 9600. And that's just our baud rate for our serial monitor that we're going to use for our numbers. So that's pretty much all we're going to need for the initial setup. And then we're just going to go in here and we're going to enumerate. And we're going to call these count states. Then we're going to put our curly key brackets. We're going to do st underscore off, st underscore counting, and then st underscore done. There we go. Then we need to just set our default count states. So we'll call those count states. Count state equals st underscore off. Now we're going to get into the initial loop. So we're going to do void loop, little parenthesis curly key brackets right there. Then we're going to do int value 1 equals analog read sensor 1. So that'll read our first sensor that's connected to A0 on the Arduino. And then we're going to do int value 2 equals analog read sensor 2. And that's going to read the sensor plugged into pin A1 on the Arduino. And now we just need to do switch and then count state. And then we can do another open curly key bracket. And now we're just going to do our cases. This is very similar to a lot of other projects that I do. I'm not an expert coder. I know there's probably a lot simpler way to do this, but this is also just a way that's easy to understand as well. So first we're going to do case st underscore off. Then we're going to put a regular colon there. Then we're going to do count off value 1 and value 2. That means it's going to use value 1 and value 2. We're going to put our semicolon and then break. Next, we're going to do case st underscore counting. Put our colon. We'll just call that one counting. I don't want to call it counting. Let's do value 1 and value 2 because it's going to be using those as well. And then we can do break. Then we're going to do case st underscore done. Our colon. We'll call this count done. Then we're going to do value 1 and value 2. There we go. And then we do break. If I can type. Now we can go into doing the individual states. So the first state we're going to do is the off state. So we're going to do void count off. And then we do int value 1, int value 2. Then we start our curly cues. All right, so this is basically something that's going to be tripped by the first sensor in it. So we need this to save this value of time. So we're going to do something called start millis, which is the variable we saved up, one of the unsigned longs. And we're going to do equals, parenthesis, millis. Now what that is basically millis is the time from when the Arduino plugs in and starts up to whatever that reading is. So millis is going to be, that's what it is at that moment. And then we're also going to do count state equals st underscore counting. So we can go ahead and move on to the counting state. So we'll go void counting, parenthesis, int value 1, comma, int value 2. Do our curly cues. And now we need it to stop when the second sensor is tripped. So we'll do if value 2 is, I forgot to put it in parentheses there, is less than 500. Put our curly cues. Then we'll do end millis for our second unsigned long that we need to store equals millis then we'll do count state equals st underscore done. And then we'll do our semicolon, and that is it for the counting state. Now we need to do our last one, which is void count done. We'll do int value 1, int value 2. So now we need to get what our time from the first sensor to the second sensor is. So we're going to use that variable time1 that we created up at the top equals, and now we need to do a little bit of math here. So we're going to do end millis, which is the value 2 reading, so the sensor 2 reading at the end, minus start millis. So that's going to be the end time minus the beginning time, which will give us the time in between. That's just math right there. And then we're going to do serial dot print ln time 1. Let's go ahead and check it. Oh, had a little error there. There we go. Let's try that again. All right, so we can go ahead and upload this to our Arduino. I've got my two sensors in position and I've got my serial monitor up, and I have a little train right here. Obviously, because I'm set up next to my computer, I can't take it all the way over to my layout. But we're going to go ahead and run these across, and I'm going to show you how this works. So we're going to trip the first sensor, and then trip the second sensor. And you can see that we're getting a value of 2789. Now this is very basic, nothing crazy, but that means 2.789 seconds between sensor number 1 being tripped and sensor number 2 being tripped. So you can use that to adjust your values by whatever you need to. So let's say you're set at the middle 50% power, or you set at a middle speed step, depending on what method you're using. You just adjust your locomotive until it gets to where that number's pretty close on both locomotives at the 50% mark, and you can also do that at the 100% mark and whatever speed step you are in between. So that program works great, but what if you don't have a computer that you can easily bring to your layout to be able to do speed matching? Well, you're going to need another screen attached directly to the Arduino to tell you this value. So we're going to do that now. Now, the first thing you need to do is you need to grab one of these 2-line LCD screens. They're fairly cheap. I picked up 2 for $10, and you want to make sure they have the I2C board on the back. Now, they have a couple of different connections, and you're going to do the VCC and the ground pins just to the 5-volt and ground connections. It's why I'm using the breadboard for this particular setup. And then you want the SDA connected to your A4 pin, your analog pin A4, and your SCL pin connected to Arduino analog pin A5. Now we just need to add the functions for the LCD screen
onto this code. So we're just going to add some stuff to it. The first thing we need to do is we need to add a library to this sketch. Now, a library basically has a bunch of code in it that's already prearranged that you can just add to it, and boom, it is in there. So we basically need to add a library so that the Arduino can write on the LCD screen. So we're going to go up here and we're going to go to File, Sketch, Include Library, Manage Libraries. And this is going to bring up all of our available libraries. The one we're looking for is called LCD I2C. So we're going to go ahead and type in the search thing, LCD I2C. And it's still got a bunch of them, but they are in alphabetical order. So we're going to scroll down. Until we see it right here. Now, I already have it installed, as you can see, but you would just highlight it right here. You would select the most up-to-date version, and then you would click Install. Once you do that, your library is going to show up right here in the Include library. You'll go all the way down here to the Contributed libraries, and you'll see LCD_I2C. That's the library we just installed. So if I want to put that in here, you got to put that at the very top. You just go to Sketch, Include Library, then go down to LCD_I2C. Boom, it is included. Next up, we need to tell our Arduino what kind of LCD screen we're working with. And there's a couple elements to this. So first of all, we're going to do LCD_I2C. That just is our library. And then we're going to do LCD. And then we're going to do this 0x27. Now, this is the address for our LCD screen. Now, the screen I'm going to link should have an identical address. If you go and buy one different, it might be different. So I'm going to link a tutorial on how to figure out what your address is on your screen right up here, as well as in the description below. So you can check that out if you have an issue with where you can't figure out what's going on. So the next thing we're going to do is we're going to type a 16, and 16 is basically just the number of characters per line that you have. So there's 16 spaces for characters on the screen. Then we're going to type a 2, which is how many lines are on the screen. There are 2-line LCDs, there are 4-line LCDs, so the one we're using is a 2-line LCD. And then we're going to close that up and put that in parentheses. So that is everything that we need to do to get this thing up and running. So the next thing we want to do is we're going to add some startups for the LCD screen. So you know how we start the serial monitor by typing in serial.begin. So we're going to type in lcd.begin. And that's all you need to do. That'll start it up. Then we're going to do lcd.clear. That will clear anything that is on the LCD screen and have it ready to go. Then just to make sure, because sometimes it happens, we're going to type LCD backlight, and that will make sure that the backlight is on for the LCD screen. Then we also need to do LCD dot set cursor to 1, 0. And that's going to set your cursor to 2, 0. And that's going to set your starting cursor position for when your LCD screen prints out something and types it out. We're then going to just add a little bit of something. Just for a little bit of fun here, we're going to do lcd.print. Then we're going to put quotations within the parentheses and do speed match end quote, and then close that up. And then we're going to do LCD set cursor. We're going to go to the next line, and we need to, for the next word, we're actually going to start the cursor at the 5th character position. So we're going to type 5, then do 1 because it's on the 2nd line, and 0 is the 1st line. And then we're going to do LCD dot print, do our quotations, ready. That's the big modifications for the setup, and those are the biggest modifications you're going to have to do. We have to do a few more, but nothing really crazy. So let's go ahead and scroll all the way down to the done state, because we're not going to do anything else with these two states. The count off and the counting are going to stay exactly the same. So what we're going to do here is we're going to leave the serial print line on there because that's always nice to have. And we're going to do LCD dot clear, do our close. Then we're going to do LCD dot set cursor 1, 0. And we're going to do LCD dot print. And then we're just going to have some fun. We're going to put some text on here. You don't have to do this part, but it's kind of nice. Time in millis. So time in milliseconds, but I don't have enough characters to put milliseconds on there. So we're going to do that. And then we're going to do LCD dot set cursor to 6, 1. So we're going to go one line down and start in the 6th position. These are just numbers that I actually counted out in advance. And then we're going to do LCD dot print time 1. So that is basically going to, at the start of the program, you're going to see it say speed match ready, and then it's going to go through the whole program from triggering sensor 1 to triggering sensor 2, and then once it triggers sensor 2, it's going to do its little bit of math and display it on the LCD screen. And then it would be fine. This is totally fine. One little thing that I like to add to it is I'm going to add a delay of 10,000, which is 10 seconds. And that's because if you don't, you're going to have a little bit of a flicker that was just a little bit annoying to me. So I just put this delay on there for 10,000. There's a lot better ways to fix this, but this just keeps it from flickering like crazy. So there you go. This is everything we need to do. Let's just double check it. It compiles and we can upload it to the Arduino. All right, I've got the whole project set up right here on a single track. You can see it's ready, speed match ready on the LCD screen, which means that we can run a train by this and get a reading of how long it takes for point A to point B. And there we go. We can see that we get a reading of 1306. That's 1.306 seconds. And we can use that number to do speed matching. Now, when you need to take another reading, just hit the reset button on the Arduino. One thing you want to make sure when you're using this is you want to give the locomotive a little bit of time to be able to get to full speed. You don't want to start it right before the sensor, or you're not going to get an accurate reading because the locomotive may still be accelerating before it gets to the first sensor, and we want it to be at its speed step that is selected before it hits the first sensor.
Speed matching is a process that people do a lot of times by eyeball, myself included, but I'm hoping that this new tool that I have designed with Arduino is something that's going to help me do a lot more accurate speed matching, which is going to increase the longevity of my locomotive components. Thank you all so much for watching. Be on the lookout for that next video on speed matching. Until next time, I'm Jimmy from the DIY and Digital. Stay safe, be kind, and happy railroading.